Hi, I'm Rich with Inside HPC. We're here at SC13 in Denver, and we're here at the Adaptive Computing booth. Dave here is going to show us a demo. Dave, what do we got here?
Well, we see HPC growing. We're all aware that it's growing larger and larger with exascale, more and more nodes. But at the same time, we're seeing the same type of growth in terms of jobs. We're having sites go from 10 jobs to 1,000 jobs, to 100,000 jobs, to 1 million jobs. These numbers keep increasing. And so we've been working really hard to improve the scalability such that we can pull that in. But when we have workloads growing by a factor of 10 every 6 months, you've got to radically approach things differently. And so what we have here is something called the Moab Task Manager. Moab Task Manager basically gives you the ability to have nearly unlimited scalability in terms of the number of jobs that you can actually handle. Typically, in a high-performance computing scientific environment, you have a centralized scheduler. A centralized scheduler, its purpose is to make an absolutely optimal decision. What is the absolute best location? Who's highest priority? I've got 1,000 policies I have to enforce. I've got to schedule time. I've got to schedule topology. I've got to take all these things into account. And I typically have to engage with one or more resource managers, and so you have a lot of overhead in making the ideal decision. Well, in these situations where you have 10,000 or 100,000 jobs, there's a boatload of those jobs that are very, very similar. So what we've come across is the idea of let's just schedule once. Let's make the right decision for all these jobs in a group, and then bunch them up, go out, create a task pool for them, put a lightweight little scheduler out there, and zip through those as fast as we possibly can. And so if you can look over here, this is actually a slight diagram of the Moab Task Manager. It's really quite interesting because we actually set this up as an application. From the scheduler's point of view, it doesn't see 1,000 or 100,000 jobs. It sees a single job, a single task pool that it goes ahead and schedules. It understands the priority, it understands the rights and privileges, it understands the types of resources it needs, all those types of things. It makes a schedule once decision, and it creates this, goes ahead and launches this coordinator daemon together with a pool of workload that it picks up. As soon as it comes up and gets that workload, it immediately contacts all of the additional resources inside of the task pool. It lines them up, and it starts spinning out workload as fast as it possibly can. Right now, we are already seeing in the first iteration of this, we're seeing launch rates in excess of 10 launches per core per second, per node. I mean, so you can, if you have 100 nodes with 10 cores each, you're looking at a very large number. Yeah. You're looking at 10,000 launches per second. And the nice thing about this, if you need to scale up, you launch another Moab Task Manager, and another, and another. In a standard size system, you can have, if you need, 5 million launches per second, just an insanely high number. So we're not saying that you will be launching 5 million jobs per second. What we're saying is, because of this model, we will no longer be the bottleneck.
Right.
You'll be talking to your storage teams, you'll be talking to your network teams. It's not going to be us anymore. We're out of the way, we're launching you as fast as you can possibly go.